Hi all. So today we try to answer together with Jakub the question whether LLMs, which are great in reading code, writing code, processing natural language, can change how we deal with outdated legacy solutions, whether those LLMs are capable of doing something more than building a snake game from scratch. That's what we've been doing for the past year. Why legacy solutions and why outdated solutions? It's because it's a huge problem for business. It's very difficult for business to keep up their competitiveness, to stay efficient while they are stuck with outdated systems. It's hard to introduce new features and so on. So at Bluesoft we deal with a lot of large enterprise systems. So yeah, that's the problem we see quite often. But first, let me walk you through how do we understand what's the outdated system. It doesn't need to. It doesn't. Yeah, it doesn't mean to be the very old system. Sometimes these are quite young solutions which were not designed proper way. But the symptom is that it's quite expensive and difficult to add new features. Business is not satisfied with the pace of introducing new features. They expect more. Adding more developers just worsen the situation. Sometimes these are the solutions that, sorry. Yeah, okay. Yeah, sometimes these are solutions where the knowledge about them evaporated somehow, so there are not more people who built that solution in the organizations. There are some dark places in the solution which we don't want to encounter, and we avoid them. These systems are hard to integrate with the rest of the architecture, so developers have to be very creative about how to integrate with them. And I would say that the main symptom to call the outdated system, legacy system, is the amount of maintenance it requires, amount of effort to keep it up and running, amount of energy and part of the budget which is consumed for the system maintenance. Sometimes this also might be the systems which work efficiently, deliver what they have to deliver, but the technology is outdated, and digital resiliency and some other regulations will force organizations to migrate those systems. And the last one, and this actually is a huge problem also for businesses, it's not fun to work with those systems. So people are coming, people are leaving, the retention is huge. The more people coming, the more leaving, the problem getting worse and worse. So that's more or less how do we see the legacy solutions that we'd like to do something about. And this picture summarizes quite well the situation. So we know the pain points, but there are not so many willing to do something about that. Why? Those modernization or migrations projects are difficult. Many tried, many failed, many surrender to do that. It's not only about building system from scratch, but also understanding the system, about migrating the data, about understanding what's inside the system, which is not well documented, and so on and so on. But that's actually what we are doing for the past year. Together with a team, we are building Modernize. We have three main capabilities. One is to provide system documentation for such systems which are lacking this documentation. We also build the automation for incident solving in such systems. And the last one, which is our goal, to enable and support modernization of such systems to new architecture, to new building blocks, let's say. From the user perspective, we expose different types of interfaces. The main one is these chats in general, where you can ask any questions, solve problems, solve incidents. We also generate so-called boomer documentation, like a Confluence, Notion, static documentation for the systems. We expose graphs so we can help stakeholders to understand dependencies and how the system is organized. Also integrate with ITS to be a part of the workflow to solve incidents, more or less. So today we're gonna dive a bit deeper into technology, what's behind that system. So yeah, let's start with we'll go through the architecture of our solution, type of the challenges we have to solve during the past year in working with multi-agent system, how to manage memory, how to build some reasoning capabilities which are strong enough to actually help us solve the problems that we have seen. I hope that we won't look like this guy to you, explaining what's behind Modernize. So let's start with architecture. We have 4 groups of agents in our solution. These are the planners, which strategize how do we want to approach solving given problem. Solvers, which are about reasoning. Workers, they are executing the steps. They are mining the code, analyzing logs, building the code, and so on and so on. And gatekeepers, which are the self-reflection implementation for those agents, just to improve the quality of their conversation. They communicate with each other in a natural language, which is, let's say, a cool one, because they can be just a part of our team and we can communicate with them in a natural way, what we do. But that's a challenge to integrate with the external environment. So we needed to provide them some information about the external system. So to translate like a natural language query to provide right code, to provide right data, to analyze logs. And these tools, I say in some cases, might be separate small projects or at least small presentation. I show you example how do we do that for a code. So providing right context to the agents when you have undocumented code, that's not quite easy solution. Naive racks, which are optimized for natural language processing, they won't process the structured data, which is code. They won't build the right context to the agents. So we just needed to approach that differently. We needed to build that documentation for the system to document the code. So what we do is we extract the code structures into the graphs and we document them using LLMs. So we have every single node documented. We document that bottom up, so starting from single methods, single variables and so on, and we go to the top. We document, we use graph traversal approach to document this from different perspectives on a different level. We also enrich those graphs with existing documentation, if any available. So that gives us the ability to query the code with that natural language. But we go even more. We do even more. What we do is we use some cool stuff, which you know probably from the graph theory, from the university, stuff like Leiden algorithm to identify some communities, to identify modules, to understand what processes and what modules are within given systems. So we do quite complex reverse engineering for the system in order to understand what's inside and document that in a way that both human and agents can use that knowledge to for their purposes.
Okay, so now here we have our multi-agentic system, and we have an example of them chatting. So we have agents, problem, and tools. So here is an example of a problem. So we asked our system to help us with a client with such a phone number that got 404 yesterday. And the first solver proposes to do such a step. And the conversation goes on and on for 20 messages. We have tool calls, tools responses. And then if we ask what was the first message, what is some detail about the client, the agent will not be able to answer that. And here we come to the first problem with multi-agentic system, is the memory. So when we have long conversations for complex problems, such as that we solve that have 100 steps, and we have long tool outputs, and the thoughts and conclusions going through agents, we can, and because of the limited context window, we will not be able to answer the first question. So basically you can say agents forget, and they need some advanced memory. So the first approach is MemGPT. Maybe you have heard about it. This is a paper from UC Berkeley, and they said that we should implement a memory within agents that is similar to how memory works in a computer. So basically the top row is the RAM memory and the bottom one is the ROM. And in our initial experiments, we gave a silly example of Robert that is sitting to my right and has an allergy because today it's raining with noodles with Highlander cheese. The 100K tokens later, with an agent with limited context to system K tokens. Without MemGPT, the agent was not able to answer this question and it failed miserably. However, when we used MemGPT, it was able to accurately say what was the first question. However, with our complex problem, we found out that MemGPT failed with long tool outputs, and what is very important for us, it failed to improve agent knowledge over time. And what is more, the retrieval of information is based on naive RAG, which, as you know, can get easily biased and be not very accurate. And we needed a custom approach to summarizing and retrieving tool outputs. And also we need a customization because we are dealing with a very specific domain. And moreover, data aggregation is not possible with just a pure MemGPT. So that's why we propose our custom memory management. So each agent has its memory manager and a graph that it calls and stores information via tools. And this enables to aggregate the knowledge from the past and very accurately retrieve what was happening within the certain conversation when solving a certain problem. So now we have a problem, we have agents and they have memory, but what to do now? How they should work, how they should interact together. If you just put developers in the room and tell them, hey, this is a problem, maybe they will do something, but it's better if you provide them some methodology. So people use Scrum, Agile, and so on. And the first methodology that we propose is to use standard operating procedures, so that whenever you have a problem, we have an idea more or less how to solve it, so that you solve the problem much more accurately. And we have 4 building blocks of standard operating procedures. So the first one is human in the loop, so that human always is there and helps agents guide them towards the right way. The second is reasoning and automatic reasoning, and this is about extracting information from a big system. And then we need scoring and ticket clustering, about which I will tell you more in a second. So starting with a human in the loop, here is another example of a conversation. We give an agent task to analyze some transaction from logs, and the agent proposes to do a certain step, and then we say that, hey, we don't agree. And this is an example of human in the loop. And from this information, agent is learning and improving his knowledge over time. The another way is a bit more automatic way, and automatic reasoning to search through solution space. So probably you have heard about chain of thought. So basically you tell an LLM to think step by step, and as you know, it improves its accuracy. But there are more advanced techniques. So the first one is tree of thought, so that you come up with multiple thoughts and check which one works and only go forward with ones that work. The more advanced version of this is graph of thought, so you have multiple thoughts, and then when you go to the next step, you can combine 2 good thoughts from the previous step. And the more advanced version of this is a state machine of thought. There was a very nice paper about it. So it's trying to go the right path based on the past trajectories and past conversations. So this is really building knowledge about a system over time. But so the takeaway from that is reasoning enables search in the solution space, and we can do this automatically, which is very cool. And now the only problem is, how do I score the solution, right? We have a complex problem with multi-steps. How do we find which nodes are not correct solutions? So that's why we need scoring. And for that, there is LLM as a judge approach. And for our case, the case of root cause analysis, this is a difficult problem to just put a conversation to such an LLM and score it, because it easily gets biased, because it will say, oh, I found logs. This is very well done job, which is often not true, because you retrieved logs, but these logs were incorrect. And also there is a very high variance because of that in output scores. And the LLM as a judge as a whole works only because assessing text properties is easier than generating it. So we developed our custom scoring solution. So when you have a conversation that could be very long, hundreds of messages and thousands of tokens, we first generate the conversation summary so that we extract the conclusions from it. And then we run the evaluation, and this is the LLM as a judge approach. And then we run this n times, like 10. And based on that, we can get the average score, which is much more accurate and representative of what actually happened in the conversation. It doesn't work just straight away. It's very important to have a good prompt, both for summarization and for the evaluation prompt. And basically, to do that, you have to have some ground truth conversations. So you have to score some manually, like 10 or 20. And then you can calculate the error and ask yourself, is this score satisfactory? And if it is, then happy path, you can deploy it. And if not, you can evolve prompts and continue on and on, trying to find the proper LLM as a judge solution for you. So now with all of that, when we want to start automizing some certain problems, we need to find similar problems, because when you have a IT system, many things could go wrong. So what we did is a classic data science approach, and we started with clusterization of incidents. So this is the example from a real system. For example, you have Google payment issues or electronic service purchase issue, and they are shown on this plot. So now we get some incidents from a certain cluster, and we run them multiple times automatically, or either with a human in the loop that guides the agents towards the right path. So now we need to generate from that the SOPs, and we got inspired by the fun search paper from Google that was published in Nature. So basically what they did is they used the graph of thought techniques and evolved their programs and then evaluated that. So what we do is that we evolve our SOPs and then try to evaluate them with our LLM as a judge to find the proper SOPs to solve a certain problem. So to summarize how we create standard operating procedures, we start with clustering incidents, finding a cluster that we want to automate, and then we solve incidents in this cluster, either in automatic way with our advanced reasoning prompting approach or with the human in the loop. Then we score those solutions, and based on that, we can generate SOPs. And here's an example of such SOPs we have created. So we store them in a graph, and this provides us with great flexibility because we move to the next step only when a certain condition is met. So as you can see, from one point we can split to two different paths based on a condition, or if the condition was not met, keep circling in the same step until you reach the desired state so you can move on. And also one important caveat here is that our proposed solution to search space, it works. However, in such system, it's often really important to have a so-called tribal knowledge. So that there is this one old guy that knows this system very well, and the human-in-the-loop approach turned out to work very well. And with just a few runs in a certain cluster, you can really gain a lot of knowledge and have a best go at automating this certain cluster. And this SOPs is really something important, because you can just throw a problem at our agents, and even without prior knowledge they can sometimes solve it. But if you want to deploy this to production and have a robust solution, the SOPs really are a game changer. So now back to Michał, he will tell you more about one advanced incident that we have solved.
And the best results till now we have, of course, from learning from human. It's like having someone who can show you actually how to work with given problems, and later you can recreate the same way of approaching the problem. This one I'm gonna walk you through is about a real-life example about some old system where back in the time you could buy some digital content, digital access via SMS, and later you have you can pay by invoice or something like that. It's a telecom system, and here we have a problem where one of the value-added systems which delivers such a content cannot authenticate because there is a problem. The VAS signature would be calculated incorrectly, and that's all the knowledge we have about the problem. This is passed to the agents, to the solver, so it starts reasoning, it starts thinking how to approach the problem, and the first step is to, okay, let's search the logs for the transaction ID we have. Let's see what are the requests and responses via in a logs, whether we can have some more information about that. There are some tools which are called to search the logs, and later when the logs are delivered, the agents start reasoning, okay, now I found those requests, responses, I have the data, so now a good approach would be to understand how this VAS signature is generated. So let's figure out whether we can find this information in system documentation. So human agrees that, okay, please do that. They use tools to query the graph to see whether, to query the documentation, actually graph, and see whether they can have this information available. They have this information returned that, okay, VAS signature is calculated in the following steps. This is like a static documentation they found. But later, in a couple steps later, the agents agreed, okay, we need to find how this is in particular implemented in this system. So, okay, let's find the VAS signature verification implementation in a code. They start searching the graph, and here is interesting case because they found some code which is about the VAS signature verification, but later the self-reflection gatekeeper found, okay, this is a test class. So you shouldn't rely on test class, you should rely on some particular method which is verify VAS and check how that's implemented. So after getting that code, here we have a situation where the agent generated a sample string to small part of a code to calculate this VAS signature and compared to the one that system was using, and found a couple of differences. The first one, which was the true cause of the error, was that the encoding of ampersand in the VAS name play wasn't encoded correctly. And this was a real problem on a production, not so easy to spot when you have a system you don't know, and especially there is some strange way of building validation strings, authentication strings, and so on. And we were maybe not surprised, but a good example how those agents can use different tools. They access the logs, they access documentation, they access the code, and were able to reason based on that, okay, this problem is in particular here in the name of the VAS signature name. So more or less that's the what agents can perform at this stage where we are. With this technology, we built like 3 main capabilities for working with such a legacy, outdated, or just existing systems. That with the system documentation, what we can do right now is to provide the up-to-date documentation. Also do that in a form of chat, which is very convenient to have the information about the system exposed to the team. We can also generate Boomer synthetic documentation, static documentation in a Confluence and so on. So that's value itself, especially in many cases where they are a system on a production. People are no longer there. Those who are there are disappearing, and we don't know what's inside and what's the approach to answer that. That might be one of the approaches to see what's inside. What we do is also the incident solving. That was the example I showed you. So we were able in the systems that we integrated with solve up to 80% of incidents, starting from the first line where a lot of incidents are easy to automate because it's very often a quick look into the data or a quick look into the logs. Okay, we haven't found that, we found that, okay, allocate there, that, and so on. But also on the third line of support, we were able to provide a substantial value to the team. They were actually amazed. Those agents are not a problem for them to work, but actually helpful from very early stage and can provide the support for them in solving incidents. But our goal is to actually build a framework and some building blocks to enable system modernization. So at this stage, what we do with such a project, we do reverse engineering and we build a knowledge graph based on the code and existing documentation. What we do later, we incorporate subject matter expert and business context to this graph to have the documented system end-to-end, both from technical and business perspectives. And we later use capability maps to discover some modules, dependencies between those modules, which helps a lot how to plan system modernization. You have different techniques. You can strangle the old system. You can approach a big bang approach that you just kill a system and introduce a new one. And again, without knowledge about how system is built, it's hard to plan how to modernize it. So we have a team of agents that provide support for architects, analysts, also developers, so they can translate the old legacy code into some new code. That's not that we can generate whole modules at this stage. We can generate some function implementation or some particular logic implementation at this stage, but we hope to orchestrate them in a way that we will be able to build bigger building blocks. At this stage, we are looking for some partners who want to join us and develop this technology, which is behind Modernize. We're also looking for partners who are willing to validate the technology, and they are having problems which we described more or less. That might sound strange, but we like some outdated legacy solutions. Sounds like a lot of fun, but for us with those LLMs, it's actually a very interesting topic how to deal with those. So feel free if you are interested in joining the team, either to develop tech or validating this tech. We are open to just reach us out. Thank you.
Let's have some questions. Who wants to question our speakers first? Be brave.
Thanks. I'm really impressed. Curious because what I saw on the diagrams and in the content, as far as I understand, this is code analysis, incident analysis, and log analysis, right? And this is the data sources that you scrape. And the way I'm thinking about this is, I think you've mentioned this around the end. Are you able to isolate modules and maybe describe in some way using either these knowledge graphs or somehow cluster the modules and describe the communication between them, assuming zero knowledge about the system that, understanding the source code.
Do you want to answer?
Yeah, so this is exactly what we want to do with the capability maps. So we can integrate with any code base that is huge and have a spaghetti code, and from that we can, using this Leiden algorithm or any other clustering like algorithms, find some parts of code that do a specific thing. And what we mainly use this for in modernization is to find the first part of the monolith system that we want to take from it and implement it as a microservice. I don't know if this answers your question.
It does perfectly. Thank you.
So this is purely statistical or data processing algorithms which are applied to the structured data which is caught, and that gives nice results. Also, later algorithm can detect interesting communities, not purely based on the code connection, but these are done based on the description of the code, based on the both the nodes and how close they are to each other, and how what is the dance of given connections, let's say. So this gives really nice results, not only to understand how system is built, but also enrich the graph to provide better context to the agents, which later can analyze that knowledge to perform the task you asked them.
Have you considered implementing this multi-agent approach in, for example, other things in the company, like dealing with compliance in security incidents, or like dealing with databases, old databases?
Yes, we are dealing with compliance and security, but that's at this stage it's a nightmare to integrate with a production, not in a way that you're asking, but maybe I answered this question first. It's a nightmare to convince large organizations that we'd like to have a read on your production logs, like a safe one, because it's those agents cannot harm your system. They can read. Very often we rely on some on-prem models like Llama. We do not send data anywhere. But this is, I think, organizations are not yet ready to expose or give access to such a data to the agents. I think it's some type of a mindset change needed here. But in terms of helping to solve the some security or compliance errors, because that was your question, yes, we haven't tried that yet, but actually, when you perform some security analysis, you query logs a lot. You analyze the data which you have either on the Elasticsearch or history. So I don't see why we cannot be helpful here. But we focus at this stage more on the some repetitive incidents, so we can free up the team so they can shift their efforts to modernization on the later stage. So what we want to achieve at given stage is that we lower the cost of maintenance of such a system, so we dedicate bigger part of the budget to the modernization efforts and support that, so we can, without additional investment, can enable modernization. So this is main focus for us.
All right,
yes.
But if I can add to the question, so you're saying you're mostly answered about giving this app to other organizations, right? To help them, for example, deal with incidents in the future, maybe if there's a mindset change and they agree to it. But can you see, for example, implementing it in your own organization right now? Because if it's your solution, like on your servers, there wouldn't be any, I think there wouldn't be any like data leak issues or something like that.
So this in particular we are running with a couple of partners. One is big telecom right now, where we integrate with their systems, and which also Bluesoft maintains and takes care of. And there is right scale to apply such a complex system. When you have some help desk with 5 tickets a week, there's no make sense to apply something like that, because the effort, the business case is hard to build for that. So we are very opportunistic, and whether we have a system which makes sense to apply, to integrate with, we just chase that.
All right, thank you.
Any more questions? Or we close the session? Thank you. Thanks a lot very much for your presentation.
Thanks for having us here.
Thank you.
Answers to the questions. Round of applause for gentlemen.